Okay, so I'm here to talk about causality, actually. And this is this hard problem where, ideally, we build features and products for the web, for apps, for bots, for whatever else we're building, and we ship this new feature out, and metrics improve the next day, right? That's the theory. But of course, reality is we build a feature, we change, we deploy to the web. Metrics may get better. Metrics may end up worse. Metrics may end up neutral. And then we have everything else in the world to worry about as well. And this really, of course, is correlation versus causality. This is the major issue we're trying to work on, and this is what A/B testing is about. This is what A/B testing solves. To make sure we're on the same page, here's A/B testing in a slide. We take a population of users. Everyone who visits our app or bot, wherever we can randomize users, we can test. We change one variable that we want to test. We compare A and B, and we choose which is better. Pretty simple in theory, pretty easy to get your head around from that perspective. A couple of examples, a fairly trivial one. Maybe you want to call it, change a call to action to say search flights rather than search. Pretty simple. But also can be complicated changes. For example, a full new redesign. Here's a recommender engine we've added to the homepage. So simple plus complex changes, everything can be A/B tested. This is what we're working towards. And the case is pretty clear. It is that, well, this is a scientific approach. This is a scientific way of working. And because it's a scientific way of working, any associations we make are always more interesting when they're causal. If an interesting association is causal, it means that we can make better decisions. We can make decisions on data rather than relying on opinion, relying on intuition. Both of those things are super important. But if we're using data, we're going to end up testing ideas with real users. This is the key thing. A/B tests are with real users on our products and not, just surveys or smaller groups. And the major fundamental, insight below that is actually experiments help beyond that with some of the human biases we have. So you may have heard of things like confirmation bias. When we look at data, it's really easy to try to prove ourselves right. It's easy to try and find data that kind of backs an idea we had. You may have heard of things like IKEA effect, where if we're building something, we overvalue it relative to the exact same thing. And experiments actually correct for this human nature. This is the key, that by A/B testing things, we take out a lot of these problems. At Skyscanner, we love experiments. We run experiments at huge scale. This is a bit of a vanity graph, but kind of shows you where we've been over the last year. We launched towards 300 experiments per month across all of our products. And fundamentally, the key challenge we've really had scaling this is there's over 40 teams running these experiments. And they're all over the world, as mentioned in the introduction. Every one of these locations mentioned have a team running A/B tests, at least one team running A/B tests, some many. All of these locations are hiring, by the way, if you're looking to get involved with this kind of work. But we've arrived over time at this philosophy, design like you're right, test like you're wrong. And the idea is pretty simple. It is we want to be creative when we're coming up with ideas. We want to use the evidence we have about things. We want to make sure we're trying out lots of new ideas and lots of different opinions. But when we come to test things, we want to work critically. We want to work as scientists. We want to try to disprove them. We want to be very skeptical. And this framework is something we've extended into our products as tooling, but also as this philosophy that we work towards. And I'll spend the rest of the talk sharing why this matters and some of the things this corrects for. There's a blog later you can read more detail. So I'll focus the time we have on some of the problems. The first is that A/B testing is easy in theory, as I mentioned in the introduction. It's pretty straightforward, but in practice, it's really easy to arrive at the wrong result. It's really easy to get it wrong. In fact, our early teams used to comment that experiments could have a split personality. One day it looks good, the next day it looks like it's worse. Maybe the next day it looks better again. We called their internal tooling Dr. Jekyll after this insight, right? That Dr. Jekyll and Mr. Hyde, there's this whole split personality thing. But this isn't true. This is just a misunderstanding of the data. We'll come on to that in a minute. So the hypothesis kit we've developed is pretty straightforward. It just introduces a couple of key ideas to standardize things. First, there's a way of making a prediction that's clear. Everyone can use the same rules. Everyone can apply the same insight to that. Everyone can share things easier. But the test like you're wrong section is a crucial one. And this is where we're doing something called a power analysis to work out how many users do we need, how long do we need to test for, what sort of impact can we expect, how many treatments can we apply. And all of these things aren't straightforward. I'll give you a few examples. So this first is selection bias. It's actually pretty hard to get the right population for an experiment. As an analogy, I could use the amount of people in this room. There's a lot, including right around the back. So if I'm giving this talk and asking for some feedback later, and everyone can hear, that's great. but if actually only the first half of the room can hear, my experiment is going to be massively overpowered. And this can mean two things. One, we make a change, the metric doesn't change. Is that because there was actually no effect? Or is it because there wasn't enough users? And these things aren't easy. Second, not well known, is that multiple comparison is a pretty tricky thing to work out. There's a tendency to add more treatments, to test more ideas at once. There's a tendency to compare many metrics. Especially online, it's easy to get hundreds of metrics that you care about. But the more metrics you add, the more false positives you have. The more treatments you add, the more false positives you have. Simple illustration here shows that the industry standard significance levels of 5% would give you a 5% error rate. But add a few treatments and it's toward 20%. So how do we correct for that? How do we think about it? Really crucial. Also, p-hacking is a pretty big thing that this toolkit's trying to avoid. And that is, if you deploy an experiment, it's really easy to segment things, find winner, find signal in the data that's not real. Again, it's easy to visualize this as an AA test. Imagine an AA test makes no difference, just two things that are the same. But if you compare the data enough times, you'll find significance, just by the probability of how the tooling works. Because in an AA test, all p-values are equally likely. So if you see something that's outside the significance threshold, but you're tempted to check it, just remember that's probably just chance. And as we go towards scaling up this program, as I mentioned, one of the key ideas would be if you just maximally power everything, it's easier. Just A/B test at 50-50 all the time. It avoids some of these problems. But that would introduce some new problems, and we're really keen to work on testing on the least amount of users possible so that many teams can experiment. Right now, for example, you can see that more than 250 experiments are running at the same time on Skyscanner. So if you think about that amount, then it means there is no true Skyscanner, right? There is no product. It's just always a combination of lots of A/B tests. And the thing we need to avoid is this, right? So here's 3 experiments that overlapped. One on the bottom saying, get more out of Skyscanner, a feedback tab, another that says, get more out of Skyscanner. So if this is 3 teams running 3 valid hypotheses, how do we ensure that they don't interact with each other and don't clash with each other? There's a whole lot of infrastructure we've put around it. And also, this idea of experiments becoming more like our product, there's lots of them, and we're testing things all the time. It's actually changing how we think about building products entirely. So in a traditional sense, a standard A/B test would be build some product, build some code, build some feature, test that feature, accept it maybe, and then either implement the code properly, cause a new sprint, or reject that code entirely. But it's not really efficient with the amount of things we're doing. And what we'd be moving towards is not trying to design the feature up front, not trying to say this is the outcome. Instead, just trying to make things super configurable, making our products really easy to set up various configuration elements that you could combine together, maybe into one test, and let the experiments figure out what the feature should look like. As an illustration, here's one example of an imaginary feature that maybe had a control group like this. You may want to collapse some data. You may want to add some ratings, provider list, swap positioning, set a preferred option. All of these things could be one experiment, but how could you possibly choose a winner out of that first attempt? So we'll build a product in this way, and then with experiments we can try unlimited combinations of this and work out which is better for our users. I'll finally leave you with one more idea on testing like you're wrong, because this framework we shared is around forming hypotheses and how to construct things. But there's a few more things to that. First, experiments aren't only about win or lose. It's not just about finding winners. Of course, that's the nice thing. We want to find winning experiments often, and we do with the amount we run, of course. But really, it's more around our intuition and how we confirmed that or surprised it. This is the more important way to look at A/B testing in my perspective, because actually surprising results are the most important insight. If we just test things that we think will work and we confirm it, that's great, but that would only move at the same speed as competitors who aren't testing. We're just trying things that are maybe obvious. And also, you'll be surprised how often that your intuition will fail. You'll be surprised how often things that even are no-brainers don't improve metrics that you would expect. We have this initiative internally called Fail Forward that I like a lot to promote this sort of thinking, that when you run experiments, testing like you're wrong is so fundamental, it's crucial. Here's a blog, you can read more on that. This is a very short talk. I don't have time for questions now, but I'd love to hang around later, and anyone's got any questions, grab me there or tweet me at that number and we'll talk more. Thanks.